Okay, 4.5, we're gonna talk about solving quadratic equations by finding the square roots of things. Okay, square root, a square root of a number, s. If r squared equals s, a positive number s has two square roots. So you have the square root of s and you have the negative square root of s. So we know that 3 squared equals 9, but we also know that negative 3 squared equals 9. So anytime you are taking the square of something, you will give me two answers, a positive and a negative. If you do not give me two answers, you are incorrect. Okay? Anytime you are taking a radical of something that has a positive radical that you're taking, the square root of something, the fourth root of something, the sixth root of something, the 12th root of something, you have two answers. Only when you take the odd root of something, 3, 5, 7, 9, is it one answer. Okay? So you're gonna have two answers. We have a couple properties. Product property and the quotient property. If I have two numbers multiplied together inside of radical, I can separate them and take the radical of both and then multiply those answers together if it's easier. Okay? So they gave us radical 18. I know 18 breaks down into 9 times 2. We do factor trees for this a lot of times. Do you remember factor trees? Personally, that's my favorite way of dealing with it. Okay? So 18 is 9 and 2. 9 breaks down into 3 and 3. Remember, if you're doing a factor tree, it has to be a pair to come outside of the factor. So if I have 9 and 2, I break 9 down into 3 and 3. Here's a pair. So I end up with 3 radical 2 left over. Okay? So that's how they get that example there. Now, quotient, they have radical 2 over radical 25. What's wrong with having a radical in the denominator spot? Can you have a radical in the denominator spot?
No.
No. So if, in this case, this one works out fine because I get radical 2 over 5 because 25 has a perfect square, yes? If I had 25 over 2, okay, then I have a problem because I get 5 over radical 2. That can't be there, which means I have to multiply by the opposite reciprocal of it, yes? So that it cancels out, and I'd be able to go from there. Or multiply by radical 2 so that you get 5 radical 2 over 2 on the bottom. We'll talk more about that. Let's look at, I have lots of examples today. Simplifying all of these examples. Let's try this.
So,
Tyler.
awesome, chapter.
Okay, just what you think. Okay, so let's simplify radical 27 first. So if I have radical 27, how does 27 break down?
9 and 3.
9 and 3? And what does 9 break down into? 3 and 3. So I end up getting 3 radical 3. Yes? 3 radical 3. Your answers on your homework tonight will be in radical form, not in decimal form unless they tell you. You are not plugging it in your calculator, you are showing me work. Okay, number 2 is radical 98. What's 98 break down into? What can go into 98? Pick a number.
49.
49. Okay, so 2 and 49, and what goes into 49? 7. Good, so there's a pair, yes? So 7 radical 2
Is that
is
my design?
my solution.
I'm not so lucky.
Nope.
I mean, not well.
Bye, Tyler.
Okay, so you have radical 27, you have radical 98. Now, look at number 3. It says radical 10 times radical 15. Okay? Does radical 10 break down into anything where I can take something out of it? And does radical 15 break down into anything? When I am multiplying radicals together, what I can do is break them down. And because I'm multiplying those two numbers together, it would be the same as taking radical 150, right? So if I change this, I would say, hey, it's radical 150. I can put it together before I break it down if I need to. What's 150 break down into? 25 and what? 6. What's 25 break down into? 5, 5, 6 breaks down into? Okay, so that doesn't help me. So 5 radical 6 is my solution. Okay. The next one's radical 8 times radical 28. What do they break down into? You said 2 and 4, which is 2 and 2 also, yes? And what over here?
4, 3, and 8.
4 and 7, or 3 and 8, okay? And 4 breaks down into 2, 2. Here's a set of 2s, here's a set of 2s, right? If I have 2 sets of 2s, what comes on the outside? A 4. Because this represents 1, 2, and this represents another 2, and 2 times 2 is 4. See, look, I have 2 4s, see? Okay, so 4 radical 14. Now, some division ones, square root of 9 over the square root of 64. That should be an easy one, because it's the square root of 9 over the square root of 64. I can break that down. So you get what? 3 over 8. Okay, simple. What about radical 15 over 4? What do I do there? It would break down to say radical 15 over, and so does 15 have a radical? No,
No.
because it's just 3 and 5. And does 4 have a radical?
2.
So I can leave my answer like that, because that's fine, okay? Then you have, the square root of 11 over 25, so that breaks down into the square root of 11 over the square root of 25, which gives me what? The square root of 11 over 5. Good, okay? And then you have the square root of 36 divided by 49, so that breaks down into the square root of 36 over the square root of 49. What's the square root of 36? And of 49? And that's your solution. Those are the easy ones. You like this part? Those are the easy ones. Those are the ones where we're just solving things and simplifying, okay? We're just simplifying. Then we get into some other stuff. Rationalizing the denominator. This is what you will not like. Rationalizing the denominator means I cannot have a radical in my denominator spot. So I have to multiply the top and bottom by the opposite or by the same thing. If I have 5 radical 2, okay? If I have the square root of 5 over the square root of 2, I cannot have the square root of 2 in the bottom, okay? So I simply multiply the top and bottom by radical 2. Because here, I would get radical 10 on top, and on bottom I get radical 4, okay? Which gives me radical 10 over 2. So I just multiplied it so that I could get a perfect square. Does that make sense? Okay? That's the easy part. The hard part is where we have something like down there where it says 3 over 7 plus radical 2. I cannot have this radical in the denominator. So I have to multiply the top and bottom by the opposite of what this sign is here. So 7 minus radical 2. 7 minus radical 2. This is technically in parentheses now, okay, because I have to do a little foiling. Now on the bottom, I'm going to teach you a trick. You can skip the middle steps because they will cancel. Because what's 7 times 7 right now?
49.
49. Okay, what's 7 times negative radical 2? What's 7 times negative radical 2? Negative 7 radical 2. What's 7 times positive radical 2?
7 radical 2.
Yeah, so those would cancel, so I don't even need to do those. If I just do the outsides, 7 times 7, and radical 2 times negative radical 2, what's radical 2 times negative radical 2? Negative radical 4, because I'm multiplying. Up top, I've got to distribute. 3 times 7 is, and 3 times negative radical 2 is negative 3. Okay, now, the bottom we can still simplify a little bit more, yes? Okay, what is radical 4? 2, so I get 49 minus 2. So my simplified answer is 21 minus 3 radical 2 over 47. Okay, and none of that can be reduced. Now, your book might write the answer like this. Let me show you. They might write it like this. As 2 separate fractions. Okay, both are the same thing. I always write it like this and just reduce from there. But they'll write it like this and reduce 2 separate fractions. so it kinda depends. Okay, so don't freak out if your answer's not exactly like the book, it could still be right. Okay. So, we are going to solve some problems. Remember when we set things equal to 0 and we factor things out, we go ahead and solve for x, yes? We're gonna do the same thing with radicals. So, if I have 3x squared plus 5 equals 41, how would you start to solve this? What would you do? Subtract 5.
Because five.
Yes, because here's the deal, I want all the x's on one side, I want all the numbers on the other. Because you're going to have to solve by taking the radical of both sides, because you have a square.
Couldn't you?
Because here's the deal, if I subtract 41 to the other side, Kaden, I hear what you're saying. If I do this, is this factorable?
Why don't you just subtract?
If I do this, then I get this, right? 3x squared minus, what's 41 plus 5? What?
36. But then it's a.
And then you would factor out a 3, and you would get x squared minus 12, right? Okay. That's gonna take you longer later on than what I'm gonna show you here. Okay, that's why. So, on this, you can do it that way, you are correct. I could do it that way, and if for some reason it wasn't factorable, then I would have to use the quadratic formula and all that fun stuff. Or, I can do it this way by saying 3x squared equals 36, yes? Now what would I do from here? Divide by 3, and you get x squared equals 12. Take the square root, and x equals plus or minus the square root of 12. 12 breaks down into 3 and 4, and 4 breaks down into 2's. So plus or minus the square root of 2, radical 3, okay? So in the long run, it's gonna be quicker to do it this way. It's kind of a shortcut. So we're gonna leave answers like that in this form. Now I put a plus and a minus because I'm taking a square root, so don't forget to do that. You have a positive 2 radical 3 and you have a negative 2 radical 3. If I plug either of those in here, it makes the equation correct, positive or the negative. Okay? So then we get something like this, where it says 1/5, parentheses, z plus 3 squared equals 7. So 1/5, parentheses, z plus 3 squared equals 7. How would I go about solving this first?
Divide
What'd you say?
Divide by 1/5.
No, not divide by 1/5. What? Multiply by 5. Get rid of a fraction, we multiply by the reciprocal. So multiply this by 5, right? Multiply this side also by 5. This cancels, leaving you with z plus 3 squared equals 35, yes? Now what would I do? How do I get rid of a square?
Take the square root.
Take the square root. So then you get z plus 3 equals plus or minus radical 35. Does 35 break down into anything for me? Just 5 and 7, that doesn't work, right? So I leave it as radical 35. Now what do I do? Yep, subtract 3, so that you get z equals negative 3 plus or minus radical 35. So my answer would be C, negative 3 minus radical 35, negative 3 plus radical 35.
Why couldn't they just write plus or minus?
I mean, you can, I'm fine with that, not a problem. Okay, so you have to work everything backwards is what we're doing essentially here, okay? You wanna get z by itself, you wanna get x or whatever variable by itself, you gotta work backwards. So if it's multiplying by a fraction, you gotta multiply by a whole number. If it's subtracting, you gotta add. If it's whatever, you gotta do the opposite, okay? And the last slide of the day. Okay, when an object is dropped, its height h in feet above the ground after t seconds can be modeled by the function h equals negative 16t squared plus h sub 0, okay? Where h sub 0 is the object's initial height in feet. So So we just plug a number in there, okay? The graph of h equals negative 16t squared plus 200, representing the height of an object dropped from an initial height of 200 feet is shown. So that diagram is when I drop it from 200 feet, that's what it looks like, okay? The model h equals negative 16t squared plus h sub 0 assumes that the force of air resistance on the object is negligible, thank you. Also, the model works only on Earth. For planets with stronger or weaker gravity, different models are used, okay? It says, for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? What do you think we need to do to solve this? What do you think we need to do to solve this? You literally have to do one thing and then just rearrange a problem. Do you have an equation?
Yes.
What's your equation? Negative 16t squared plus h sub 0. What does h sub 0 stand for? Nope.
Neutral.
The height
The
and
height,
feet.
yeah, the height and feet.
So just plug in 50.
Oh, beautiful, Kaden. Just plug in 50. So I'm gonna say 0 equals, we're gonna replace 0 for h because we're trying to figure out the time, okay? 0 equals negative 16t squared, and then it's plus 50, yes? How would you solve for t from here? What would you do? Subtract 50 from both sides. And you get negative 50 equals negative 16t squared. Now what would you do?
Square root of the square root.
Divide.
Divide by negative 16. You gotta get t squared by itself first. So then t squared equals negative 50 over negative 16. Now what would you do?
Take the square root.
Take the square root. What's the square root? Okay, well, this makes it positive, right, when it's like that. What's the square root of,
Couldn't you take the square root a step before? You can't.
well,
'Cause it'll be like the
you
same
wanna
thing.
take the square root of, if you take the square root, you have to take it of, the problem is you have negative 16 and you have negative 50. You don't know what it, can you take the square root of a negative number?
Oh, so you do that to make it positive.
Yes. So now I have the square root of 50 over the square root of 16. What's the square root of 16?
4.
4, and what's the square root of 50, do we know?
You can do
No.
5 and 2.
You can do,
5 radical 2.
yeah, 5 and 10, which is 5 and 2. So I
You
can do
25 and
5 radical 2, I can do 5 radical 2 over 4, but how many, what has to go with this? Plus or minus? So I have
Wouldn't it
plus,
just be a plus because you can't have negative time?
that's a good call, good Kaden. So because it is time, it technically, yes, in this case, the only answer would be 5 radical 2 over 4. We write our answer as this, and then we come back and use logic, and we say, due to it being time, the answer is 5 radical 2 over 4, because time cannot be negative. Good. That is what this whole section is on. Okay? Radical, radicals.